Here's another example of a hypothesis test involving a population standard deviation, and this example is also similar to exercises 9 to 14 in section 10.4. The standard deviation of the prices of MRI, or magnetic resonance imaging scans, charged by hospitals in Orange County is $125. A consumer advocate in Los Angeles suspects, however, that the standard deviation of the prices of MRI scans charged by hospitals in Los Angeles County is higher, in other words, less consistent, than that in Orange County. The consumer advocate obtains a random sample of 41 hospitals in Los Angeles County, determines the price each hospital charges for an MRI scan, and then calculates the sample standard deviation to be $164. Is there sufficient evidence to conclude that the standard deviation of the prices of MRI scans charged by hospitals in Los Angeles County is higher, or less consistent, than the standard deviation of the prices of MRI scans charged by hospitals in Orange County? Use an alpha of 0.01 level of significance. Also note that a normal probability plot and box plot indicate that the prices of MRI scans charged by hospitals in Los Angeles County are normally distributed. So there are a couple things to note in the description of this. These researchers are comparing the standard deviation of prices in Orange County, which is $125, to the standard deviation of prices in Los Angeles County. And this consumer advocate in particular suspects that the standard deviation of the prices in Los Angeles County are higher than in Orange County. And so to test this out, the consumer advocate obtained a sample of 41 hospitals, and from that sample calculated the sample standard deviation of the prices to be $164. And so again, the question that the consumer advocate is asking is the standard deviation of prices in Los Angeles County higher, or in other words, less consistent, than the standard deviation of prices in Orange County? And that word higher is going to affect how we'll write the alternative hypothesis. Higher is going to indicate greater than, and so ultimately in the alternative hypothesis we'll use a greater than symbol. Also, this makes a note that when they say a higher standard deviation, another way of saying that is the data is less consistent. And remember that at the beginning of these notes, there was an exclamation about standard deviation. When the standard deviation is very large, that means that your data is less consistent. Your data values are more spread out. And that's the concern, is that in Los Angeles County, the MRI scans are more spread out in their prices. So step 0 would be to summarize the information and identify any point estimates. And in this study, they are comparing the standard deviation of prices in Orange County to the standard deviation of prices in Los Angeles County. The consumer advocate obtained a sample of 41 hospitals, measured their prices for their MRI scans, and calculated a sample standard deviation of $164. So The sample standard deviation of MRI scans charged by hospitals in Los Angeles counties, $164, is higher than the standard deviation of prices of MRI scans charged by hospitals in Orange County, which was $125. So this seems to support the alternative hypothesis. However, we will need to test whether the sample standard deviation of the prices of MRI scans at these hospitals in Los Angeles County is significantly higher, and therefore sufficient to conclude that the population standard deviation of the prices in Los Angeles County is in fact higher than those in Orange County. So step one will be to state the hypotheses, the null and the alternative. Again, we're using sigma to represent the population standard deviation. And sigma represents what is unknown in this hypothesis test. The unknown is the actual population standard deviation of prices charged by hospitals in Los Angeles County. So in this problem, Orange County is known. It's known what their standard deviation of prices are. But what's not known is the standard deviation of Los Angeles County prices. And so here are the hypotheses. The null hypothesis is the standard deviation of prices in Los Angeles County are about the same as the standard deviation of prices in Orange County. The alternative hypothesis is greater than. It has this greater than symbol. And remember that that has to do with the fact that the question that the advocate is asking is whether the Los Angeles County standard deviation is higher than the Orange County standard deviation. So you would write that as the standard deviation of prices in Los Angeles County is greater than the standard deviation of prices in Orange County. And so again, I've written these hypotheses as full sentences just to give you clarity on what they mean, but you don't necessarily have to write full sentences when you're doing your own research or on a test or on the homework. Step 2 would be to verify the requirements. I won't go into this into detail. It's the same two requirements. There's not a whole lot to calculate, at least not for what we'll do in our class. You'll just have to look in the description and make sure that they mention that this is a random sample, and also mention that that they have already verified that the distribution is normally distributed. We'll go on to step 3, test the hypotheses. So there are 2 or sometimes 3 main approaches. We'll go over both approaches, but again, you don't necessarily have to use both approaches when you work out the homework or test problems. The first method we'll look at is the classical or the test statistic approach. And we'll start by first sketching out the chi-squared distribution probability curve and find the cutoff chi-squared value. Note that this is a right-tailed test because our alternative hypothesis was greater than, and also alpha is 0.01. That's the area under that right tail of the curve. This is what it might look like. Here's an alpha of 0.01. Here's the cutoff for that right tail. We'll go to table 8 to look for that critical cutoff value. And remember that in table 8, there are 2 things you need. You need the degrees of freedom, and you need the area under the curve to the right of the critical value. The degrees of freedom are n-1, so 41 minus 1, which is 40. The area under the curve to the right of the cutoff is 0.01. This is a right tail test. Alpha is the area of that tail, and that's the area to the right. That's what you actually need for the chi-squared distribution table. So we'll go to the table and look that up. We'll look for 40 degrees of freedom, that's down here, and look for an area to the right as being 0.01. So there's the 0.01. We'll see where those line up. It looks like it lines up right here, 63.691. And that's the cutoff for our right tail. The next thing that you'll do is calculate the test statistic. We'll use this formula for the test statistic. The population standard deviation of the null hypothesis was $125. Sample size was 41. The sample standard deviation was $164. Put all those numbers in there, and we'll come up with 68.8538. And the last thing is to determine whether that test statistic is inside or outside the critical tail. The cutoff was 63.691. Our chi-squared value is 68.8538. Remember that the curve, it starts at 0 and it just goes to infinity this way. So 68.8538 is past that cutoff. It's maybe somewhere around here. So our test statistic is inside the critical tail, and that means that the results of this study are unusual and significant, and our conclusion would be that we reject the null hypothesis. The second approach is the p-value approach. And the first thing that you want to do is to calculate the test statistic. So just like in the last approach, we would take those steps, put those numbers in, we would come up with this result, 68.8538. And to calculate the p-value, you want to keep in mind the definition of a p-value. For this study, the p-value is the probability that a random sample of 41 hospitals would result in a sample standard deviation of MRI prices of $164 or more. And here we're using that phrase "or more" because the alternative hypothesis was greater than, assuming that the alternative hypothesis is true. So note also that the results of this study can be summarized by this test statistic, 68.8538. So instead of defining the p-value this way, we could state it this way. The p-value is the probability that a random sample of 41 hospitals would result in a chi-squared test statistic of 68.8538 or more, assuming that the null hypothesis is true. And we can write that as the probability that you get a chi-squared value of greater than 68.8538. Notice again that this greater than inequality matches the greater than inequality of the alternative hypothesis. So one way to calculate this probability is to use a calculator, and it never hurts to draw out the curve again. So here's our curve. This is on the right side of the tail. This cutoff chi-squared value is 68.8538. That's the left boundary. The right boundary is infinity. It just goes on forever this way. So on the Casio, you would take the same steps as before, except now the lower bound is the 68.8538. The upper bound is infinity, so you want to put 10 to the 99. Degrees of freedom is 40. Similar on the TI 83 and 84. Lower bound is your chi-squared value. The upper bound now is infinity. And when you put those values in, you get a p-value of 0.0030622. Compare that to the alpha. That value is less than the alpha, which was 0.01, and so we reject the null hypothesis. So the conclusion is that we reject the null hypothesis. There is sufficient evidence to conclude that the standard deviation of prices of MRI scans in hospitals in Los Angeles is higher or less consistent than the standard deviation of MRI scans in Orange County.